Welcome to lesson 8.6. Today we're going to be looking at all the different statistical measures we can use and deciding which ones are most appropriate for our data set. One new term for today is the word outlier. An outlier is a data point that is way different than all the other data points in the set. So it lies outside the rest of the data, which means it's an outlier, right? Got that? So this first part is about choosing the best measure of center to describe a data set. Now remember, our measures of center were mean and median. So which to use? So Gary is looking at his scores on weekly quizzes, and he wants to know the best way to get a sense of how well he is doing. So first what we're going to do is we're going to organize our scores on a dot plot and see if there's outliers or clusters or anything that would give us insight into how well he's doing. So we have an 88, so we can plot that data point, and an 87, and a 91, and I'll keep going till I have all the data points on my plot. There they are, and I counted them up. I have 10 dots on my dot plot, and I have 10 test scores, so I know that I got them all. And as I look at this, first thing that stands out to me is this 65 over here. That is what we would call an outlier. It lies outside his normal grades. We seem to have a cluster of grades here in this range, a little bit of a gap here, and then we have this. So all these scores, I would say, kind of are pretty consistent. The one that really stands out again is that 65. That's not really like him, is it? So the next thing we're going to do is find the mean and the median and the mode and the outliers of the data. So I need to organize my data from least to greatest. And there it is. And now I'm going to find the easier things first. So I'm going to find the median. And the median looks like it's halfway between 90 and 91. That would be 90 and a half or 90 and 5/10. Of course, you could add those two numbers up. 90 plus 91, 181 divided by 2, you get 90.5. The mode is the data point that happens most often. Looks like the only one that repeats is 98. I've got two of those, so the mode is 98. I do have that outlier that I spoke of. That's 65. That lies outside the normal range of our data. And the mean is going to equal the sum of all the values, not this, of course, that's not actually a data point, but all the 10 values, quiz scores, and I'm going to divide by 10. If I add them all up, I get 887. If I divide by 10, I move my decimal over 1 point, and I get 88 and 7/10. Just giving a common sense, it should be greater than the smallest value. It is. It's bigger than 65. And it should be less than the greatest value, which is 98. It is. So it kind of makes sense. And now the big question is, what's the best measure of the center of his data? Is his data centered more around 88 and 7/10 or more around 90 and 5/10? So that's the big question. Now I drew in green where the mean and the median fall in our data set, and they're pretty close to each other. It's not a huge difference with 10 scores, but I do think the median is closer to the middle of his data set if you don't pay attention to the outlier. The outlier really drives the mean down. So the outlier, 65, it pushes the mean below most of the scores. Outliers really affect the mean. The median, on the other hand, is not affected by outliers, so it's a better measure of center. Let's look back at the graph in our list and see what we're talking about. Here's our list of scores again. If that 65 became an 85 or even an 89, okay, the median would be the same. It wouldn't change, but the mean would increase by quite a bit. All right, see if you can interpret this data. Gary scored a 70 on his next weekly quiz. How would that affect his mean score? So we're going to add to this mix a 70, right? And we're going to calculate the new mean. We know the old mean was right here. And so we need to calculate a new mean and see what that 70 did. Maybe you're already predicting what that might do to the mean score. Gary also says that he usually scores a 98 in his quiz. And 98 is the mode. It's the score that happens most frequently. But do you agree with Gary? Does he usually get a 98? Check that out and see if you agree with him. For this next part, we're going to be choosing the best measure of variability to describe our data set. Variability, remember, is how much the data varies. In other words, how spread out it is, how clustered together it is. So we have our mean absolute deviation, and we have our interquartile range, and we also have our regular range. So those are our possibilities. And for this first part, part A, we want to choose the measure of variability best to be used for John's quiz scores. So let's go ahead and look at his scores. They're right here. And thankfully, they already have them in order from least to greatest. Wasn't that nice of them? As I look at it, I'm looking for outliers, numbers that are outside the normal range. And it looks like we're high 80s and 90s, all these data points. But then we have the 65. That, my friends, is an outlier. It's not like him to get a 65. And like we learned last time, if you have an outlier, that throws the mean off, right? It throws your average off. So the best way to describe his quiz scores would be by using the median, because the median is not affected by an outlier. I know what you're thinking. You're thinking, Mr. Edwards, median is a measure of center, and we're talking about variability. You are correct. And once we've made this determination, we look at the variability that goes with it, and mean absolute deviation goes with mean, and the interquartile range goes with median. So we're going to pick the interquartile range as our best measure of variability, or how much the data changes. Well, coming back up to our data, to find the interquartile range, okay, the IQR, this is equal to the third quartile minus the first quartile. And I could do my box and whisker plot, but I don't need to. All I need to do is come up and find the median of the data. It's right there. There's 10 scores, so 5 on each side. And then I need to find the middle of the lower. That's going to be 87. And the middle of the upper, that's going to be 93. And that is the first quartile, right? The middle of the lower. And third quartile is the middle of the upper. So I'm going to do 93, take away 87, and I get 6 as my interquartile range. And remember, the interquartile range is the middle 50%. So that means half of John's tests are in that range of 93 to 87. They're pretty tightly bunched there. We're going to look at Yoshi now. We're going to look for the best measure of variability for Yoshi. So you're going to look at Yoshi's scores. Okay? You're going to look to see if there are any outliers. If you think there are outliers, then we're going to go ahead and use median in IQR. If you look at that data and you say, there's no outliers there, well, then you're better off with mean and mean absolute deviation. So give that a try. As an aside, also, if you don't remember how to do IQR, I just did an example, right? And if you don't remember how to do mean absolute deviation, well, go back to your notes for the last lesson, or even go back to the video for lesson 8.5, and you can maybe remind yourself how to do that. Now we're going to take a second look at John's scores, and the French teacher said she'll drop the lowest quiz score for the grade. Or if we drop that 65, what would be the best measure? Could we use the mean absolute deviation now? Try it, see what you find out. And we have our straight up practice. For this first set of scores, we're going to find the mean, median, and mode of all the scores. And then we're going to ask, let's see, is the median or the mean the best measure of center for the data? Explain why. Remember the importance of outliers in this situation. Well, give it a try, and I'll see you next time.